I'm going to go ahead and dot this with a little orange, just so I know that's the one we're not replacing that on. And one thing I wanted to mention, I want to show you, if we can get a little pointer here, my razor blade out. Let's see if we can get this thing to focus. Come on, there we go. If you look on this circuit board, you'll see on these components these little red dots around a lot of these components, and that is glue. There we go, we got focus. That is glue, and so when you take off a glued component, like if you try to do it with hot air, it won't necessarily break down the glue. It's best to do it with a soldering iron and get a little extra solder on there and rub that soldering iron onto the glue and help get a little wedge and pryage and stuff on there to break the glue joint, because otherwise these are thin circuit boards. You can overheat the circuit board and pop the circuit board trying to get that glue to release with hot air. So it's probably best to either get in there and pick a little bit of it away and put a little leverage to it once you've got it all molten with a soldering iron. But the soldering iron does a pretty good job of breaking that down when you put a little pressure to it. So alrighty, here we go. I desoldered the wrong thing. Happens. Sometimes you gotta go back. And fix the old mistakes. Okay. We replaced them, we cleaned them. Now comes the tricky part. I've got this on a switch so that we can do it, but here is number 6. Let's slide these up so we can kind of get this centered. And we are going to put our meter on 20 volts, and we can use the negative of the ground here. Well, first thing we need to do, stand back, switch on the power to it. No explosion. Now I'm going to put my meter on 600 volts, and I want you to see the voltage across this. There we go. 167 volts across that cap. So be careful. You know, if you're an idiot and you're doing this stuff, you're doing it at your own risk. So we're going to turn this back down. Now you'll see the labeling on these: plus 5 volts S standby, SB, standby return, that should be the ground, AC/DC standby. I'm not sure exactly what that means. Oh, the AC/DC, and then AC/DC or AC in something else. I'm not sure. So what we can do, the AC/DC standby is what we want. So the 5 volt standby, do we have 5 volts? I'm checking. I do not see 5 volts. Make sure I'm getting in there. A little pointy probe. No 5 volts. Nothing. Alright, so you come over here. We got, oh, need to up our voltage here. We have 168 going into one side of the fuse, 168 going into the other side. Should have 168 volts. Yeah, we don't have anything coming out of there. And over here, do we have it at the diode? No, nothing. So we're going to kill the power. Carefully unplug this. We're still at over 160 volts. Now, one nice thing about watching this on your meter is your meter actually will help drain it. But we did not get 5 volts out on this one. This is not the red dot one. So the red dot one, we left the FET in. So we replaced the fuse, those 2 resistors, and that FET, and it's still not got it done. So I'm going to make room very carefully, because remember, this cap's still charged. We're going to get this one out of the way, and we'll go to the next one. We'll see if any of these work first. Alright, I'm going to switch on power. No explosion. My 20 volt. Hey, looky there, 4.85 volts. So, we'll put our probes in there. And we want to go 5 volt standby to the AC/DC standby. I can get this in there carefully. There we go. Look at there, 12.1 volts. Power supply is on. Wonderful. So we got, notice I take that off and the voltage drops. So we got one power supply working. So if nothing else, we now have one that we can use to troubleshoot the others. So I'm going to turn the power off to this. And we're going to be real careful. slide this way, this one here. So 7 worked, 6 did not. This is 8. This is the one we did not replace this FET here because it didn't show shorted. I'm going to power it on. I'm going to check for 5 volt. Look at there, we got 4.85. We stick our probes down in here. And we do the standby. Look at there, 12.12. That one worked. I'm going to kill the power to it. It's unplugged. I'll crank my meter back up to the 600 volts. Just sitting here, unplugged. Notice there's nothing plugged in. That cap still holding voltage. Now it's dropping pretty quick. That's good. And the longer we hold our meter on there, the more it'll drop. Bam. Now that one should be safe. Now you can, after it's drained down, you can go across the terminals with like a good metal screwdriver to really make sure it's totally done. So now we can handle that one. So that one worked. 7 was the other one that worked. Let's see where its cap is. Its cap's down to 2 volts. If you get a negative on your multimeter, that just means swap your leads unless you're looking for a negative voltage. That one's about 2 volts. We can, now that's nice and low, we can turn that out and nothing. Fantastic. And then let's go over to this one, and it's still at 148 volts. So I'm going to carefully bring it back over here. And it's slowly going. So that also, the fact that these went down so quick and this one is not, tells me something is definitely wrong. We know this one did not have its 5 volt standby, but whatever is making a complete circuit here somewhere should be helping to drain this cap down, and it's not. So I'm going to take a pause here. We're going to let this cap drain. If it doesn't drain down very fast enough, I'll show you my little rig for draining caps. It's just high value resistors with some little probes on it to help do that. So we will get this thing drained down. I'll be right back. Oh, this is how it always goes. I powered up number 8 because I was going to take a couple of readings across these diodes, and I had it powered up and running, and you could turn on the 12 volt, and all of a sudden I hear this, and I had no more 5 volt. So I flipped it over, and the new resistors that I put in, see if I can get that up there where you can see it. Right there. Come on, focus. Right there, blue. And that FET that wasn't dead is now dead. This is the one that we didn't change this FET out on, and I wondered if it wasn't very good, based off the fact that these others blew, and now it popped that. So probably anytime those 2 resistors go, it'd probably be a good idea, and this fuse would be a good idea to change that FET. So now we'll have to do that, and I am out of resistors. We'll have to do a little magic of YouTube, get some more in and everything, but technically I could swap that out and steal the parts off of number 6, which is not working. Number 7 still works. number 6, which we need to finish troubleshooting, because even though we replace those, we're not getting 5 volts out, which is probably the controller chip for this, so we'll have to look at that, and I don't think I have them. I think it's this one right here, but we might be able to use this one, which has got some kind of problem over here, to steal some parts off of if we need to. So let me get that all sorted and organized. We still know number 7's our good one. Maybe I'll just do this one real quick when I get a second here to bring it back up, change that fed out, and fix those with parts off of this one or this one. And then we'll be back to 2 working ones. I'm going to put one in a case. It'll be done. And then we'll keep one of them out here to compare measurements to try to troubleshoot these others. Alright, let me get set up. Man, I can't believe I didn't catch it on video. That really stinks. It always, all the exciting stuff happens whenever you're trying to set up for a good video shot and you miss it. Okay, I swapped out the FET there and fixed the chips. Stole them from number 6 here, but it's still not working, so my assumption will be that both these need this little controller. I've traced this that FET back, and they will both go to those little controllers. Got those on order. We'll do a magic of YouTube maybe, but I also got some more resistors coming. So 7 works. We're going to case it back up. 8 will need that chip. 6 is going to need more, and then we got number 1 here. So let's put 8 to the side, because it should just need the chip. It was working. We just need that chip, I believe. We're going to case up 7 real quick, and then we're going to look at 1. So give me a minute to set this one to the side. We may rob 6 for parts to fix 1, and then see what else we got to order to fix that one up, and then we'll put that one back together. Alright, we got 7 done. I can get rid of all these bad parts. Number 1. Now number 1, get our meter over here. This one had good fuse there, but a bad fuse there. So let's check the bridge rectifier. So that's showing a short from the positive to the negative on the bridge rectifier. That seems okay. So where all do they go? So they go to this inductor. That inductor, that's got a winding that goes to this control chip, it looks like. And then this is the main power. Goes through this bridge rectifier. That seems okay. So either this transformer shorted or the bridge rectifier shorted. So let's see about taking out the bridge rectifier. And then we'll test it separate, because that's pretty easy. We'll get a screwdriver in here. maybe. Nope. Looks like we're going to have to take the ground leg out too. To get that out, if that happens to be shorted, we can steal it off of this one. And same with the, see if we have a fuse. So we need to take the fuse out also. It is those legs right there. Alright. See if my desoldering tool is hot enough yet. Goes to there. Soldering tip is not big enough to get those, so we'll have to do it the old-fashioned way. So that fuse should come out now. It says it's 6.3 amps. 6.3, yep, I've got some of those. Fire up the iron and get this heated up, and we'll suck this other stuff out. So the glare is just really tough, but we're going to be taking out those 5 solder joints. We're going to add some leaded solder to them. To make them a little easier to keep up to temperature, because we got a big ground pad here. It's heated, it's a little easier. We'll see if I can get it with my bulb here. I got some of it. I got a chunk of it. I have to order me a bigger tip for my solder desucker there, so I want to be able to take these out. With it, a whole lot easier. That's what I bought it for. Then we can get a little bit of solder braid. Just a clean piece of solder braid. See if we can suck up any more. Make sure that's loose. Hit it from both sides. And you can kind of feel when these get wiggly. Ground lug's going to be the pain, I think. We'll see. I do have a spring-loaded solder sucker that we may have to employ. We'll see. It's all free except for the ground lug, and it's a wiggly, but that ground is hot. Grab it with a little pair of pliers off the edge here while I heat that ground lug just a little bit. Get it to wiggle right out. Awesome. Now we can go back to our multimeter. Let's get some stuff out of the way so you guys can see. So the outer two were the ones that were showing short, so we can check it here, and we're still showing short, and this is not shorted, so it's something after this. Possibly that fit. It's showing shorted. See about taking it out. So we know this is probably good then. That was a big waste of time. See if we can get that back in there. Good. We'll go ahead and solder it up while we're waiting on the desoldering iron to heat up. I didn't even think to check that fit. But that's why I'm the goober, not the guru. Oh, I turned that off. I gotta clean my workbench. Trying to put all these power supplies on is just tough. Let's get one of these legs that's easier to do. It's soldered in place so it's held. And we'll go over there and work on that big ground plane. That's all back together, right? And the whole purpose of the Lego motion is to try to get the legs broke free from the walls. Let's turn that off. Get rid of these. Take this screw yet. That fit comes out. That's got a, I don't know if you can see that, but on the legs, see if we can get that to focus. See those ferrite beads there on the outer legs? If you replace this, you want to put that in there. That's going to be for a little suppression. That thing's shorted. So we need a fuse. We need that. Is this one off of 6 going to be our parts board temporarily? We have 2 bad parts. It would already have the solder beads on it. Let's see if this shows up as good. Apparently so. So we're going to put that screw down there. We're going to go ahead and get this screw out. just chuck this part because it's got our ferrite beads. And somewhere right here, we got a fuse. 6.3 amp is what we said when this came off, so let's steal this part. We'll put the screw in to hold it and solder it back up. Pull this up a lead here. Solder all that. When we come back, I gotta run to the store with the wife. Be right back, guys.